Hi all, welcome to the fourth lecture on EE302 electromagnetics. In this lecture, we will be discussing about the problems based on the concepts that we have already discussed in lectures 1, 2 and 3. That is mainly we're dealing with problems based on electromagnetic waves and one problem based on Poynting vector. So let's start. Okay, so the first problem that we have is, let's go through the question. The electric field in free space is given by E is equal to 50 cos 10 raised to 80 plus beta x AY volt per meter. And you're asked to find three parameters. You have to find the direction of wave propagation. You have to calculate beta, which is the phase shift or the phase constant. And the time it takes to travel a distance of lambda by 2. Lambda indicates the total wavelength. And you have to sketch the wave at three instances. At small t is equal to 0, t by 4 and t by 2. See now when a question is given, especially based on electromagnetic wave, the first thing that you need to identify is what kind of a medium is it. Okay, so for example, in this given question, the medium is free space. Okay, so you have to identify that the medium is free space, and everything, all equations related with free space, please write it down, which includes the fact that in free space, your sigma, the conductivity is 0, epsilon is equal to epsilon 0, mu is equal to mu 0. Okay, that is the main point. And then now, when you come to see what is given in the question, see the expression for the electric field is given, okay? So, there are a lot of details that you can understand from this particular expression that is given for the electric field, this expression for E. See, E is equal to 50. This 50 denotes the amplitude, okay, the peak amplitude of the electric field. That is, this is the E0. Now, usually we have a term e raised to minus alpha z or alpha x, depending on propagation. That e raised to minus alpha term is not present over here because the medium is free space, and in free space alpha is 0 and e raised to 0 will be 1. Then cos, this 10 raised to 8 stands for omega plus beta x. So what you have to understand here is the x associated with beta. This x denotes the direction of wave propagation actually. So if it is beta z, it implies that the wave is traveling in the z direction. If you are given beta x, it implies that the wave is traveling in the x direction. Okay, and similarly the sign over here also, a plus sign indicates that the wave is traveling in the negative direction. Okay, so if you have cos omega t plus beta x, it implies that the wave is traveling in the negative x direction. If the term is given as cos omega t minus beta x, it implies that a negative sign here implies that the wave is traveling or propagating in the positive x direction. Okay, so that gives you the direction of wave propagation. Now this AY here, this AY denotes the direction of the component of the electric field, which is the direction of component of the electric field that is given by this AY, and the unit is volt per meter. So this is the information that you obtain from the expression for E. So basically there are two things that you need to know properly. What is the difference between wave polarization and wave propagation? Okay, see, wave propagation is the direction along which the wave propagates. In this case, as I mentioned, it is the negative x direction. And from this beta x term, if it is beta x, it is x direction, beta z, it is z direction, and so on. So this gives you the direction of propagation of the wave. So what is wave polarization? Wave polarization is the direction in which the component of the electric field exists. I'll repeat that once again. The direction in which the component of the electric field exists. That direction, or that is referred to as wave polarization. So in this case, the wave polarization, the direction is A, y. That means it is in the y direction. So this particular, in this case, the wave polarization is said to be in the y direction and the wave propagation is in the negative x direction. Okay. So from that, the answer for part A is given. Okay. Because this is a plus sign, the wave is propagating in the negative x direction. Now, since you know it is free space, we have already derived this expression. Beta is omega by c. See one thing, for all the different media, the expressions for alpha, beta, gamma, the intrinsic impedance, the wavelength, and the velocity of propagation, these you should know. Okay, that is, you should know them by heart. Only then you can solve the problems. So in the case of free space, beta is given by omega by c. Actually, what is the general expression for beta? Beta is omega by v, where v is the velocity. In this case, the velocity of propagation is the same as c, that is the speed of light. Okay, c is a constant speed of light because the medium is free space. So you substitute omega, which is 10 raised to 8, divided by, in place of v, I'm substituting 3 into 10 raised to 8. And that's how I get beta. And please note that the unit of beta is in radians per meter. So, if you notice here, they've used U, that is in the Sadhiko textbook, the notation that they're using for velocity propagation is U. Okay. In other textbooks, they've also used V. I think in my previous derivations, I had referred to the notation as V. So it is up to you. You can either use U or V. Both refers to the velocity of wave propagation. Only thing is you consistently use any one notation throughout. That's all. Okay. So part B, this portion, beta is obtained. Now, how do you find out the time taken to travel a distance lambda by 2? How do you obtain that? So for that, what we're doing is, see, capital T is the time period of the wave, okay? And lambda is the total wavelength. That means capital T is the time taken to cover a distance lambda. So in order to cover a distance lambda by 2, what will the time be? That time will be T1. That time is given in this case as T1. It is T by 2. See, this is easy. Just do a cross multiplication. That is corresponding to capital T, the distance covered is lambda. So if my distance that I need to find out is lambda by 2, for a distance lambda by 2, what is the time? Okay, when you just cross multiply it, you're going to get this expression. T1 is T by 2. And the expression for T, which is the time period, T is written as 1 by F, which can also be written as 2 pi by omega. So please note, this expression is also important, and this is something that you need to know. The expression for the time period T. T is 1 by F, which is the same as 2 pi by omega. And we know the value of omega. So when you substitute, you will get the time taken to travel a distance lambda by 2. Now the third part is you need to trace the wave or draw the waveform for 3 different instances. How do you obtain these instances? You just substitute for T in this expression. See, when T is 0, E is 50 cos beta x. And you can also write it as EY because the component of V varies in the Y direction. Now when you substitute small t as T by 4, and in place of this T also substitute 2 pi by omega. So it becomes, you'll get this form, which can be further simplified as 50 cos beta x plus pi by 2, and this is the same as writing minus 50 sin beta x. Similarly, in order to get t equal to t by 2, what do? Here you substitute capital T by 2, and in place of that capital T, we can again substitute 2 pi by omega. You will get 50 cos beta x plus pi, which is the same as minus 50 cos beta x. Okay, so the expressions for E for all the 3 instances are obtained. Now we are going to draw the waveform. See, when you draw the waveform, the axis that we are marking are x. Why are we marking x? Because we have identified that the wave propagates in the x direction, and that too in the negative x direction. And why are we plotting y? Because the variation of the electric field is along the y direction. So at t equal to 0 instance, what is the expression that we got for Ey? It is 50 cos beta x, which means you draw the waveform, cos waveform, and the magnitude is 50. Okay, so I hope all of you know how to draw a cos waveform with a magnitude 50. So that is how the waveform is drawn for t equal to 0. Now for t equal to capital T by 4, how will you draw the waveform? It is, what is the expression for Ey? Minus 50 sine beta x. That means it is a negative sine wave and the amplitude is minus 50. How do you draw a positive sine wave? Positive sine wave is like this. So a negative sine wave will be just the reverse and the amplitude is minus 50. Okay. Now in the third case, when t is equal to t by 2, you're supposed to get minus 50 cos beta x. That means it is just the reverse of the first case. Okay. You just invert this waveform, you will get this. Now, there is something that you can infer from this. See, supposing I'm marking this point as P. That means the point where it is attaining this amplitude 50, this point P. Now, what happens is, this is at the instance t is equal to 0. Now, when t is equal to t by 4, since I want to draw a negative sine wave, how am I actually going to draw the negative sine wave? That is, this point, I will bring it to the origin and then start the wave from here. Okay, this point is brought here. So what happens to this point P? It will further shift this side. That is what is shown over here. Now in the third case, what happens? Again, I need minus 50 cos beta x. So it is the reverse of the first one and minus 50 comes over here. So how do I get that? From here, this point, I have to bring it here so that it coincides with minus 50. This point is brought here. That is how I get this third waveform. So what happens to this point P? That is going to further shift to the left. Okay. So actually, what does this imply? At t equal to 0, t equal to t by 4, t equal to t by 2. That means as your time is increasing, what is happening? The wave is propagating in which direction? It is propagating in the negative y direction, which is obvious if you observe the position of point P. So this is how graphically we can verify that whatever we have stated is true. That is, this wave is propagating in the negative x direction. That is verified by drawing these waveforms. Okay. So with this, problem 1 is complete. Now moving over to problem 2. So if you see, problem 1, we dealt with a medium which was free space. So for problem 2, the medium that we're going to discuss is a lossy dielectric medium. So as soon as you see lossy dielectric, the properties of a lossy dielectric should immediately come to your mind. For a lossy dielectric, sigma is not equal to 0, epsilon is equal to epsilon r, epsilon naught, and mu is equal to mu r, mu naught. Write that down. And also, all the equations for alpha, for beta, the intrinsic impedance, the wavelength, the velocity of propagation corresponding to lossy dielectric, please write it down at the side. Okay. So now let's read the question. The intrinsic impedance is given at a particular frequency. Now, if at the same frequency, the plane wave propagating through the dielectric has the magnetic field component H. So in this case, or in this problem, H is given. The magnetic field component is given. We are asked to determine the electric field component. Okay, in fact, we have to determine 4 parameters. We have to determine the expression for the electric field, the attenuation constant alpha, the skin depth, and the wave polarization. Okay, so as I mentioned earlier, what is the information that we get from here? This is H0. This 10 stands for H0, which is the maximum amplitude of magnetic field. E raised to minus alpha x cos omega t minus, this is beta. That is, in this case, beta is equal to 1 by 2 x, and it is minus x. So what does this imply? The wave is propagating. That is AK. AK represents the direction of propagation of the wave. That is in which direction? The positive x direction, because the sign here is minus. The wave propagation is in the positive x direction, and the variation of the magnetic field component is in the y direction, and the unit is ampere per meter. So in order to find the expression for E, what will we do? See, you need to find out E0, similar to H0, E0. And how will you find out E0? We know the relation that E0 by H0 is equal to the intrinsic impedance. So here H0 is known, the intrinsic impedance is also known. So we can easily find out E0. Then E raised to minus alpha x remains the same for E also. Cos omega t remains the same, minus beta x remains the same. What is one more term that is going to come over here? Theta n. That is, since this is a lossy dielectric, there is a phase shift between E and H by an angle theta n. Okay, and how do you obtain that theta n? Theta n is already given here. It is the angle of the intrinsic impedance. So that is 30 degrees. Okay. So only thing is, you should know that E leads H by 30 degrees. Okay. E, always the electric field is going to lead the magnetic field. So here, since the base equation is magnetic field, when you write it for the electric field, it should be plus 30 or plus pi by 6. Why? Because to show that E leads H. If you recollect, when we derived the expression for E and H for a lossy dielectric, in that case, E was taken as the base equation. E was written in terms of cos omega t minus beta x. So then to obtain H, we wrote it as cos omega t minus beta x minus theta n. But in this case, it is the reverse. H is given. And if you have to find out E, since E leads H, it is going to be plus theta n. And like AY, the direction of AE, what is the direction of the electric field? That has to be determined. Once you determine these things, E, the expression for E can be obtained. So how to find E0 and what is theta n I've already explained. Now how do you find out the direction of AE? See, to find out the direction, always it is easier if you can use this, what I've written here at the side. Okay. See, AE cross AH gives you the direction of wave propagation AK. Similarly, AH cross AK gives you AE and AK cross AE gives you AH. And you also have AX cross AY is AZ, AY cross AZ is AX, and AZ cross AX is AY. So these two things, if you know, how will you find out AE? What is AE? AE is the cross product of AH and AK, where AH, what is AH in this case? AH is AY. And what is AK? The wave propagation is AX. Okay, so what is AY cross AX equal to? AY cross AX will be minus AZ, isn't it? If AX cross AY is AZ, AY cross AX is going to be minus AZ. So that is how, see, you got AE as minus AZ. So if you know this, it's easy to determine the direction. Okay, so we got the direction of the electric field. It is in the minus Z direction. Now to write down, to obtain the expression for E, as I told you, E0 can be obtained using this expression. The angle is pi by 6 and you write it as plus pi by 6. The minus sign here is because the direction is negative. So minus, see here actually you got 2000, okay, because you're multiplying it with 10. If you see, the unit is written in kilovolt. That is why they have written it as 2. It is always okay to leave the answer in volt per meter also. No problem. So minus 2 e raised to minus alpha x cos omega t minus x by 2 plus pi by 6. The direction is AZ kilovolt per meter. So thus the expression for E is obtained. And I've already mentioned, what do you mean by wave polarization? It is the direction along which the component of the electric field exists. And in this case, the component of electric field exists in which direction? It exists in the Z direction. So the wave polarization is along the Z direction. Okay, so the expression for E and the direction of wave polarization is also obtained. Now to find alpha. See, this is the expression for alpha and beta for a lossy dielectric. You should be knowing these equations. Okay, beta 1 by 2 is obtained from here, given data. This is a given data. And how can you find out sigma by omega epsilon? That is equal to tan 2 theta. This also we have derived. So that is tan 60. So if you just take the ratio of alpha by beta and solve, you'll get the expression for alpha. This is basic maths, arithmetic solving. So please go through and solve. And remember the unit. See, the unit of beta, unit of alpha, unit of E, unit of H. All the units are very important. Unit of wavelength, unit of time period. So please study all those units also. So Nipper per meter is the unit of attenuation constant. And once you know the attenuation constant, how can you find out the skin depth? What is the relation? Skin depth is 1 by alpha and the unit is in meters. So this is how, so for this problem, for the lossy dielectric problem, all the 4 parameters are obtained. Expression for E, the wave polarization, attenuation constant and skin depth. So with this, problem 2 is also complete. So we discussed one problem based on free space, one based on lossy dielectric. Now here the medium is a lossless medium. For a lossless medium, what are the basic things that you need to know when the medium is lossless? Sigma is 0, epsilon is epsilon r epsilon naught, and mu is mu r mu naught. Okay. These things you should know, and the expressions for eta, as I told you, all those expressions also you should know. So here eta is given, mu r is given, h is given. You have to calculate epsilon r, mu and e. Okay. So how did you, so sigma is 0, alpha is 0 because the medium is a lossless medium. Beta 1, how did we get beta 1? From here, cos omega t minus beta x. So beta is 1. This is the expression for intrinsic impedance for a lossless medium. This you should be knowing. So here the only unknown that you have is epsilon r. So direct substitution problem. Substitute and find out epsilon r. Everything else is given. Similarly, the expression for beta, this is the expression for a lossless medium which you should be knowing. And the only unknown here is omega. So you find out omega also. So epsilon r and omega, just directly substitute in the expression and obtain. Now how do you find out E? See here you should understand H has two components. There is H1 and H2, which means E will also have two components, E1 and E2. Now this is a lossless medium, and you should understand that for a lossless medium there is no phase shift. Both E and H are in phase with each other. Theta n is 0. Okay, which means this cos omega t minus z term, sin omega t minus z term remains the same for H and for E. The only new things that we need to find out are the amplitude and this direction. Okay. See, how do you find out this direction? It's just similar to the previous problem. I'll explain AE1. Okay. AE2, please try it out for yourself. See, to get the direction of AE1, we know it is AH1 cross AK. And what is AH1? See, AH1, the direction, since there is a negative sign over here, it indicates that it is minus AX. So AH1 is minus AX and AK is AZ, the positive Z direction. Minus AX cross AZ is going to give me AY based on this rule. So that is how I get this. Similarly, find out AE2 using this rule. And how can I find out E10 and E20? See, eta is known. H10 and H20 are also known. So just directly substitute that. And then once you get E10 and the direction, just write E1 plus E2 volt per meter. That will give you the expression for E. That's all. There is no phase shift over here because the medium is lossless. Okay. So with that, problem 3 is complete. Now coming over to problem 4. So see, sometimes in the problem directly the medium will be given. The first 3 problems, the medium was directly mentioned. Free space, lossy, lossless. Some cases your problem will be framed in this way. A uniform plane wave propagating in a medium has, see the expression for E is given. If the medium is characterized by epsilon r is 1, mu r is 20, sigma is 3 mho per meter, you have to find alpha, beta and h. So this means based on these characteristics or parameters, you have to determine what the medium would be. See, one easy way of identifying is, see, epsilon r is equal to 1 and your sigma is not equal to 0. It has a value. Okay. So which means this will definitely be a good conductor. Another way of identifying is, we know that if your sigma is much less than omega epsilon, it is a dielectric, and if sigma is much greater than omega epsilon, it is a good conductor. So you can check that. That means if the sigma by omega epsilon ratio is much greater than 1, it is a good conductor. Otherwise, it is a lossy dielectric. So if when you take that ratio, it is much greater than 1 in this case. So you can infer that this medium is a good conductor or a perfect conductor. And for a perfect conductor, alpha and beta both are equal. And this expression you should be knowing. And if you substitute directly, you will get the expressions for alpha and beta. Similarly, eta also you can find out. And then how do you find out h? See, by now you should be knowing, given E, how you find out h, or given h, how to find out E. So H0 can be found out. Once you find out the intrinsic impedance, you can find out H0 e raised to minus alpha z sine omega t minus beta z. And once you determine theta n minus theta n ah. See, the direction of this h has to be determined. This you determine using the same rule. Okay. If you apply the same rule here, in this case, the wave is propagating in the positive z direction and E, the direction of E is AY. So based on this, you can find out AH if you apply this rule. So applying that rule, you will get the direction of H as minus AX. And then using this relation, you find out H0. And then just substitute those and write down the expression for H. It is okay to write the final answer in ampere per meter or milliampere per meter. Both are acceptable. Okay. So this is how you find out the expression for H. So for this problem, whatever is asked is obtained. So with this, actually, the first 4 problems, we were dealing with electromagnetic waves. That is, for whatever be the media, you should be able to find out the various parameters and expressions for E and H. Okay, that is one category of problems. Now this is one problem based on the pointing theorem, pointing vector. We have a non-magnetic medium. Non-magnetic medium means mu r is equal to 1. Okay, the expression for E is given. You have to find epsilon r and eta. Okay, so in this case, see, alpha is 0. Okay, from this expression we know, because e raised to minus alpha, that term is 0, which implies that alpha is 0. So that means the medium could either be free space or lossless. Now how do you identify whether it is free space or lossless? We can take the ratio omega by c. If beta is equal to omega c, it is free space. Otherwise it is lossless. In this case, it is not equal to omega by c. So we have come to the conclusion that this medium is a lossless medium. And then whatever data can be obtained, that is taken down, all the given data. So to find out epsilon r and eta, you just directly substitute the expressions corresponding to a lossless medium and solve. You will get the answer. Okay. So this part already we have discussed a couple of problems. So I believe this portion is clear to you. Now we're going to the next part, which is to find the time average power carried by the wave and the total power. See, time average power is the instantaneous pointing vector, and this is the total power, which is a scalar quantity. So these expressions we have already derived in lecture 1. Okay, so the pointing vector is given by E cross H. So you'll get this expression. Okay, see how you get this expression is, how do you do E cross H? You write down AX, AY, AZ as the first row. Then your E has only a Z component. So it will be 0, 0. And in place of EZ, you write it as E0 sine omega t minus beta x. Then again, beta x AZ. And then, so from here we know that since E is in the Z direction and the wave propagation is in the X direction, that means H should be in the Y direction. So when you write the last row, it will be 0 and 0 for X and Z, the H term. Now this H term, H0 can be written as E0 by eta. Okay. And sine omega t minus beta x remains the same. So since this is a lossless medium, again there is no phase shift. Your theta n is 0. And then, you just use the rule and solve it, and you're going to get this expression. Okay. So in order to find out the time average power, that is the instantaneous time average pointing vector, this expression is already derived. In place of this P, we'll substitute this. Now, in general, when you integrate sine square omega t minus beta x term or cos square omega t minus beta x term, when you integrate, you will finally come down to, it simplifies to this form, E0 square by 2 eta, and it is AX. Okay. So you know the values, you substitute, and that's how you get the expression for this. See how to solve this. I have shown it over here for cos square. See here, I have shown you how you can simplify the, see this is from another text. That's why the notations are slightly different. Okay. This P average here corresponds to this P. So in place of EM, we are using the notation E0. Okay, E0 square by eta. So cos square theta is written as 1 plus cos 2 theta by 2, and then you integrate it, simplify. Finally, you're left with E0 square by 2. And please go through this derivation. I've fully solved it. Now, even if it is, so this is the case if it is cos square. Even if it is sine square omega t minus beta z, even in that case, the only difference is this becomes 1 minus cos 2 omega t minus beta z. So this becomes minus. But then again, when you simplify, you will still get this expression. I want you to try the sine square on your own. Okay, cos square is given. The only change is, what is the only change? This becomes, you write the simplification of this form. That is, if you have sine square omega t minus beta z, this is 1 minus cos 2 omega t minus beta z by 2. Simplify, you will get the same answer. Okay, so simplify it, and then once you substitute, you will get the answer. Now, what is the next part? You have to find the total power crossing 100 centimeters square. That means the total surface area is given of this plane. Okay, the plane is 2x plus y is equal to 5. How will you find? So the total power is integral of P average dot ds. I'm going to take this P average outside. Integral of ds is the total surface area into the unit normal vector to that surface. Okay, so for P average, I'm going to substitute from here, and then dot. Now the area is given as 100 centimeters square, so that SI write it as 100 into 10 raised to minus 4. Now, for a plane of this form, how will I find the unit normal vector? So the rule is like this. This 2x plus y is equal to 5. This can also be written as 2x plus y minus 5 is equal to 0. So I'm going to consider that as some function f. Okay, f is equal to 2x plus y minus 5 is equal to 0. And to find out a unit normal vector, what I'm going to do is del f by f. Del f by the magnitude of f you have to do. What is f? F is 2x plus y minus 5. Okay, that is it's a scalar function. And del f means what? Gradient of a scalar. That will give you a vector. That is why the numerator is a vector. So this is del f. What do you mean by del f? Dou by dou x ax plus dou by dou y ay plus dou by dou z az. When you do that, you will get this, where the function f is, okay, dou by dou x of f plus dou by dou y of f plus dou by dou z of f. When you do del f, you will get this numerator. Divided by the magnitude of del f, you will get the denominator. Okay. So that is how, when you're given a plane, first of all, you bring this to this side. You write it as 2x plus y minus 5. And then take that, you consider it as f. And then you do del f by magnitude of del f. Del f by magnitude of del f. That will give you the unit normal vector. So I'm substituting the unit normal vector over here. And then simplify, you will get the answer. So now supposing, so in this case, it was a plane of this form. So whenever a plane is given in this form, use this method. Supposing you're given the area of a circle and the radius of the circle is given. So you find out the area as pi r square. And you are given that the circle is lying on plane z is equal to 0. In that case, how will you find out an? What is the unit normal vector to a circle which is lying in the z equal to 0 plane? Z equal to 0 plane is the same as your xy plane. And what is the unit normal vector to that plane? It will be az itself. Okay. Similarly, supposing your plane is x equal to 0. If you have a square, that is, you have a square and the side of the square is given. That means you can find out the area. Okay. And then to find the unit normal vector to a square which is lying on plane, say x equal to 0. What will be the unit normal vector to x equal to 0? X equal to 0 means, which is the plane? It is the YZ plane. Okay. So the unit normal vector will be AX. These are just different variations of how these kind of problems could be asked. Different configurations may be asked. You will be asked to find the total power crossing a circle or a square. Okay. And the plane can be given in different ways, like z equal to 0, or it can be given as shown in this problem. Either way, you should know how to solve. Okay. And what do you understand from that? The total power is always a scalar value, whereas the time average instantaneous Poynting vector is always a vector. Okay, these are two inferences from this problem. And these are the this is the simplification which you can go through. So these are the 5 problems which mainly covers that is, you will be able to do all problems related with electromagnetic waves and Poynting vector if you listen to this lecture. So with this, I'm concluding the lecture. Thank you.